Okay, this was a question that was asked by people in my GCSE further maths class. Now, I think this one, to be honest, goes slightly beyond what is needed for CCEA exam board, but it might be different for other exam boards. But it's actually very easy to do anyway. So I'm going to look at this one. It says solve 6 sine squared theta plus 13 cos theta minus 11 is equal to 0. Now, the problem with this one is you've got sines and coses mixed in, so that makes it a wee bit more complicated. Now, there's a wee identity, which is that sine squared theta plus cos squared theta is equal to 1. And you won't see the proof of this until A-level maths, but it's very easy to work with. But what we can do with this is we can change this. We can make sine squared a subject here by bringing the cos squared across the other side. So the cos squared becomes 1 minus cos squared. So then if we go back to our equation over here and substitute in our new, instead of sine squared, we're going to write 1 minus cos squared. If we sub it in, so it's going to be 6 times 1 minus cos squared theta plus 13 cos theta minus 11 is equal to 0. Now if we just go ahead with this and we multiply out, that's going to be 6 minus 6 cos squared theta plus 13 cos theta minus 11 is equal to 0. What I'm going to do is bring it all to the other sides, to the right hand side, to make the cos squared term positive. You'll have 6 cos squared minus 13 cos, and then that will be 6 minus 11 would be minus 5, so on the other side it will be plus 5, and then we can go from here. So what have we got? We have got our sum is equal to minus 13. Our product is equal to 30. So we want to find two numbers such that they add to give minus 13 and they multiply to give positive 30. So 30 is equal to minus 1 times minus 30. That doesn't work. Minus 2 times minus 15. That doesn't work. Minus 3 times minus 10. And that does work. So that tells us how we can rewrite this equation up here. We can write it as 6 cos squared minus 3 cos theta minus 10 cos theta plus 5, and then we can factorize this by factorizing the first two terms. You can pull 3 cos theta outside, leaving you 2 cos theta minus 1, and over here pull out a minus 5, leaving you 2 cos theta minus 1. Okay, excellent. So you've got your common bracket is 2 cos theta minus 1. The other one is going to be 3 cos minus 5, and then we're going to put this bracket equal to 0, which means 2 cos minus 1 equals 0, or we can put the other bracket equal to 0, so put this bracket equal to 0, which is going to be 3 cos minus 5 is equal to 0. So then go ahead and solve those two equations. That's going to give you 2 cos theta is equal to 1, which means cos is equal to 1/2. That will give you a nice basic angle. This one is not going to give you just as nice a one. You're going to have cos is equal to 5/3. Oh, actually, this is even nicer. Right, this happens quite often. When cos is equal to, if you remember back to your cos graph, if I do it very quickly, your cos graph goes like this. Its maximum value is 1, its minimum value is minus 1. So when this happens, we have just found out that cos is equal to 5/3. That's impossible because cos can't be more than 1. So just write down IMP, which is abbreviation for impossible, and that's that one done. So it actually becomes very easy, this question, because we've just got to solve cos theta is equal to half on whatever the range was. What was our range? 0 to 360 degrees. So don't even need a calculator for this one. This is a nice angle. CAST on your cast diagram. Cos is positive, so it's in here. And I haven't done my basic angle. What am I doing? My basic angle, squeeze that in, do cos to the minus 1 of 0.5, and that gives you 60 degrees. So 60 degrees goes in here, 60 degrees goes in here. There's my 0. So it's going to be this, my first one. First angle I come to is 60 degrees, and the second angle I come to is 60 degrees short of 360, which is going to be 300 degrees. Done.